Alright, so today we're going to talk about something called the unit circle. Unit circle. So what makes the unit circle special is that it's going to have a radius of 1. So radius equals 1. And then let me draw a picture of that. Here our y-axis, our x-axis. Try to draw the best circle I can. That's pretty good. So if my radius is 1, that means that at this point here, I'm going to be at 1, 0, and let's say at this point here, I'm going to be at 0, 1. Alright, but let's say I wanted to find out the coordinate of any point on my circle. So then we're looking for x, y. Well, the coordinates for the unit circle are, instead of being represented by x and y, we're going to represent them as cosine of theta for our x and sine of theta for our y. Alright, so let's give ourselves an example. Let's say I wanted to find, I wanted to find the x and y coordinate for when theta equals 30, about right there. Well, then I say that x, y equals, I'm plugging in 30 degrees for cosine, or pi over 6. So that is the cosine of pi over 6, comma, sine of pi over 6. Well, we know from our identities that the cosine of pi over 6 is going to be the square root of 3 over 2, and the sine of pi over 6 is going to be 1/2. So when my theta is 30 degrees or pi over 6 radians, this is my coordinate pair, square root of 3 over 2, comma, 1/2. Alright, something else we can notice is that both of these are positive because we are in the first quadrant. Let's mark that right here. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Now inside these quadrants, a lot of these values will stay the same numerically, but their signs will differ depending if they're in quadrants 1 through 4. So for instance, quadrant 1 is in both the positive x direction, here, and the positive y direction, which means that no matter what, their coordinates will both be positive. Likewise, in quadrant 3, we are in the negative x direction and the negative y direction, meaning that both of these will be negative. In quadrant 2, we're in the negative x direction and the positive y direction, meaning that our x's will always be negative and our y's will always be positive. Or if we look over here, that means that our cosine value will always be negative and our sine value will always be positive in that quadrant 2. And then to finish it up, quadrant 4 is in the positive x direction and the negative y direction. Something else that we can talk about is going to be the equation of a circle. We recall that the equation of a circle is x squared plus y squared equals the radius squared. Well, in our case, our center is 0, 0, so there's going to be nothing in addition added or subtracted from these x and y values. But we do know our radius is 1, and 1 squared is 1. So what we really have here is x squared plus y squared equals 1. Well, doing some substitution back over here, instead of saying x, I can say cosine, and instead of saying y, I can say sine. So after substituting those in, I get cosine squared of theta plus sine squared theta equals 1. This is a very important trigonometric identity that we'll cover in the next video.